Quadratic functions in general form look like f of x equal ax squared plus bx plus c. From this equation now, from this form rather, we cannot read the vertex h comma k. So in this case we have the formula here on the side. The value of h, that's the x-coordinate of the vertex, is given by negative b over 2a. We have the problem y equal negative x squared minus 8x minus 12. We want to find the vertex. I will use the formula minus b over 2a. And all these numbers are written in order. The a, b, c values are written in order. b is the number in front of x. So in the formula we have negative, and b is negative 8 over 2 times, and a is the number of x squared, which is negative 1. Negative times negative will give us positive 8 over negative 2, which is equal to negative 4. So we just found the x-coordinate of the vertex. To find the corresponding y-coordinate, substitute negative 4 in place of x into the original problem. We have y equal negative parenthesis negative 4 squared minus 8 parenthesis negative 4 minus 12. We get negative 4 squared is 16, so I can drop the parenthesis, positive 16. Negative 8 times negative 4 is positive 32 minus 12. And that will give me, in fact I'm going to go ahead and use a calculator to go a little faster on this. I have negative 16, well, really, I'll just go ahead. Negative 16 plus 32 is positive 16 minus 12, and 16 minus 12 is just 4. So that will be the y-coordinate of the vertex. The vertex is negative 4, 4. So in my table, I will place that in the middle, negative 4, 4. Now, the directions say that we want to find 2 points to the left and 2 points to the right of the vertex. So going 2 points to the left of negative 4, I will get negative 5 and negative 6. And the 2 points to the right will be negative 3 and negative 2. I will go ahead and sub in negative 6 in place of x into the original problem. We get y equal, I'm going to write here, negative and negative 6 squared minus 8 times negative 6 minus 12. So I substituted x with negative 6 and I'm just checking. Okay, now this negative stays, the negative inside the parenthesis drops because you square it, and that will give me 6 squared, that's 36, plus 6 times 8 will give us 48, plus 48 minus 12. And then I'm going to go ahead and use a calculator. So I have negative 36 negative 36 plus 48 minus 12. We get, I got 0. Let me double check. Negative 36 plus 48 minus 12. Yep, we get 0. So that's 0.0 right there. And repeat for negative 5, we get y equal negative and negative 5 squared minus 8 times negative 5 minus 12. That will give us negative 25 plus 40 minus 12. So negative 25 plus 40 minus 12 will give me positive 3. That goes right there. I will plot those 3 points. I will start with the vertex, negative 4, 4. That will be right there. Negative 4, 4. Then I will have negative 5, 3. And then I have negative 6, 0. So that will be right there on the x-axis. The axis of symmetry is the line that goes through right in the middle of the parabola. That's the axis of symmetry. So I can go ahead and read the axis of symmetry as the line x equal -4. The axis of symmetry is always the x-coordinate of the vertex, this number. Next, do you see how, if I connect those 2 points, might as well go ahead, the parabola looks down, okay? And that's because of this negative at the front of the parabola of the equation. Now, you can continue for the other 2 points by substitution, just like we did on the side. But I know because there is perfect symmetry at -3, I will get this point right there. I will get y equal +3. Those 2 points will match. And at x equal -2, I will get y equals 0. And so I can connect them like that. This is 0. Those 2 points will always match. As long as you take the 2 points before and the 2 points after the vertex, and they have equal distance from the vertex, that will be, the answers will be identical. So you don't have to actually show substitution on the side. Now, let's go ahead and find the x-intercepts. Well, you can look at the picture here and see the x-intercepts are where the graph crosses the x-axis, and that will be at x equal -6 and x equal -2. We just found those values right here, -6 and -2. So we'll go ahead and write those down as points. That will be -6, 0 and -2, 0. The y-intercept is where the graph crosses the y-axis. So to find the y-intercept, we will let x equal 0. So into the original problem, replace x with 0. We have -0 squared minus 8 times 0 minus 12. These are 0 terms. We get -12. So the y-intercept is 0, -12. So looking at my picture, if I extend this y-axis, -12 is right here. So as this parabola goes down, eventually we'll go through this point right there. Okay? And it's gonna kind of open like that. Okay? And that's because it's gonna have to cross the y-axis at -12. The domain of a parabola is always -infinity to infinity because we have no restrictions. Restrictions happen only when we have a square root or when the function is a fraction, when there is a denominator. In that case, we set the denominator equal to 0 because we don't want to divide by 0. In this case, we don't have a denominator and we don't have a square root, so there are no restrictions. The domain of parabolas is always -infinity to infinity. Now, the range is all y values. So to find that, I'm going to look at the picture and I'm going to reflect every point from the parabola to the y-axis. The highest point on the parabola is the vertex. And if you reflect that on the y-axis, it's going to be at point 4, y equal 4. And then every other point in the parabola reflecting on the y-axis will go from 4 all the way down. And in fact, it will keep extending all the way down to -infinity because this parabola keeps extending down. So what I need to read now is this blue segment that I shaded on the y-axis. So it will be from point 4 all the way down. When we read the range, we want to start from bottom up. All the way to the bottom is where -infinity is. And then you're going to go all the way up to point 4. And at 4, we will use closed interval because point 4 is included. It is part of the parabola, it is the vertex. And that point is always included in the range.